YouTube, this is my fifth video in my module on measures of central tendency, in which we're going to find all of them. That is the mean, the median, the mode, and as a matter of fact, we're going to find the mid-range as well. In order to do so, I've got a really small data set here, but we say a small company consists of the owner, the manager, a salesperson, and 2 technicians, all of whose annual salaries that are listed here, okay? So we say assume that this is the entire population. This is actually important. We assume it's the entire population. We actually have everybody's data here, so we're going to write with notation that's a little bit different. But let's go ahead and start with the mean, okay? So when we talk about the mean, recall that we mean it is the sum of all the data divided by however many data there are. So let's go ahead and start by finding the sum of all of our data by adding these all up. So we say 50,000 plus 20,000 plus 12,000 plus 9,000 plus 9. We get 100,000. So we're going to go ahead and list this here. We say the sum of all of our data we use to represent an x, or we use x to represent our data. We say the sum of this is 100,000, and this is in dollars, okay? As far as like how many things we have, I probably shouldn't use a lowercase n here. I should use an uppercase n. And the reason why is because we're talking about we actually have the data for the entire population. So we can see we have 6 employees here. So to find the mean, we usually use either mu or x bar depending upon whether we're talking about parameter, so the population statistic, or just a statistic of a sample. In this case, we have an entire population, so we're going to use a Greek letter mu. So we say the mean mu is equal to 100,000 divided by 6. So if we take this $100,000 divided by 6 here, we say 100,000. Actually, 5. Whoops, sorry. We do have 5 data, don't we? So we have 5 data here. That'll work out a little bit more easily. I was like, wait a minute, if we divide by 6, it's not going to be pretty. We say 100,000 divided by 5, we end up with 20,000. So our mean annual salary here is $20,000 for this one workplace, okay? So let's talk about the median. The median, of course, means we'll count in from the middle, so we'll count in each way until we land at a middle datum here, or we'll average 2 data, but in this case we say median. Okay, the median comes out to be equal to exactly $12,000. Okay, and the mode, what happened most frequently is we saw 2 people with a $9,000 annual salary, just helping out being text there. Okay, so one more statistic that we haven't defined up until now would be this: is the mid-range. And when one thinks about the range, recall that when we discuss the range of the data, we say R is equal to the max minus the min. So this is what leads to people getting confused here when we talk about mid-range. Okay, so we say mid-range. The mid-range has not much to do with the range. It is abbreviated MR, but it is more the average of the max and the min. So kind of what number would lie perfectly between the smallest value and the largest value in this case. So we say the formula for the mid-range here is min plus max divided by 2. So in this case, we'd say our mid-range, we say mid-range, would be abbreviated MR, would be our min, so it's a 9,000, plus our max is 50,000, all split 2 ways. So we end up with this half of 59,000. So that'd be, let's see, 59,000. 24,500, 59 divided by 2, 29.5. So we say 29.500, and this is in dollars, okay? So the last thing I want to do here is kind of compare these, because these are all what we refer to as measures of central tendency. They kind of tell us where the middle of our data is here. So you notice with the small data set, some of these statistics, occur very far apart from one another. If I were to say which data are better indicators of how things really are more in the center, I'd say that the median and the mode are very good approximations, where in this case the average is kind of off. It's kind of off-ish. And the reason why it's off is because we had this very large salary for the owner that was making $50,000 a year, okay? So in terms of outliers, we refer to very large or very small numbers as being outliers typically. We say which statistics that we calculated are affected by outliers. So we say heavily affected on the average, affected by the 50,000. Also, you'll notice down here that 29,500 is not very typical. You see that we had, a lot of people under 29,500. And the reason why is because we also, again, had this $50,000 included in this average, okay? So this is also heavily affected. Whereas, and I suppose we could switch over to like, I don't know, let's go with like a golden color here. We say things that are resistant to outliers happen to be these two measures in the middle. And the reason why is because if you were to consider adding another datum in there, the median with the middle of the data would shift slightly, but not very much because you're only adding in one datum. And the mode wouldn't really shift unless you added another 9,000 or another 12,000 or 20,000. But basically, the mode and the median are very resistant to such, outlier-ish additions to the data set. So, yeah, last thing I'll mention is this. The mean, we interpret what this means. We say this 20,000 is kind of like the most typical case. This 12,000 here is meant to communicate to our audience that half of the annual salaries are above 12,000 and half are below. The mode is just telling us, hey, this is the most common thing we see at this workplace. And then the 29,500 is more, again, kind of a representation of the middle-ish of our data. So all measures of central tendency.